Hello, and welcome to today's webinar. My name is Adam Golov, Marketing Communications Manager at Data Conversion Laboratory, and I'll be your moderator today. Before we get started, I wanted to let you know we'll allow time at the end of the webinar for questions and answers. So please write your questions in the chat area as they come to mind. If we don't have time to answer them all, we will make them available on our website. Next slide, please. For those of you who are not familiar with DCL, we convert and organize content to create electronic documents, populate databases, publish on the web, and basically get it ready for tomorrow's technology. Next slide, please. DCL's services help you refine your document conversion strategy, identify document redundancy, extract metadata, and transform legacy and future documents for real needs, today and in the future. Next slide, please. We serve a very broad client base. Next slide, please. Spanning all industries. Next slide, please. Today, we are thrilled to introduce Richard Dominelli, Lead Software Engineer, DCL. Rich brings over 25 years of system architecture experience to DCL and has been solving problems and designing resilient solutions on everything from mobile devices to state-of-the-art web-based metadata management systems. And Alan Lieberman, Special Projects Manager at DCL. With a deep and comprehensive technical background in both computer software production and large-scale database design and applications, Alan is currently overseeing a project to capture legal and regulatory data from government and agency websites, allowing the content to be ingested, analyzed, and processed by in-house systems. Alan joined DCL in 2012, following 25 years with Information Systems Department of Davis, Polk & Wardwell, a leading global law firm, where his most recent position was Manager of Software Design and Systems Development. Alan holds a BA in Mathematics from City College of New York and an MS in Computer Science from Polytechnic University of New York. Without further ado, welcome Rich and Alan.
Thank you very much, Adam. This is Alan Lieberman. Thank you all for joining. Our subject for today is web crawling, science or art. Before we get too deeply into that, let me just make sure we're all on the same page about web crawling. What is web crawling? So simply put, we're all familiar with websites and web pages. The act of crawling is collecting the information that is on a page and downloading it offline into a system so that it could be kept for future use. Another name for web crawlers are web spiders, indexes, but they're all, as the image shows, they go to specific pages, ingest the content, and save it in a system. Next slide, please. Now, why crawl a website? The first answer is probably the one that all users of the web are familiar with. When you want to find information, you go to an indexing site, which has already done all the work for us and has gone through the whole world to gather information, store it, categorize it, make it searchable, and allow the links to be presented so that anybody who's looking for the information follows the link to the actual site without having to find it themselves. So that's really the most pervasive use of web crawling. But there are others such as backup archiving, so that there are offline versions of websites at certain times. There's redundancy availability. If the actual system is not available, there are alternate ways to get to them. And as the slide shows, there can be various utilities that are very much helped by having the information offline. But what we're going to focus on is really the legal application of web crawling. In the days not too long ago, everything was paper-based. Huge volumes, loose leafs were kept by law libraries and lawyers' offices so that they could access versions of laws and regulations that affected their practice. Today, more and more information is available on the web, sometimes only on the web, certainly faster on the web than on paper. And it's essential for the legal industry to be able to access the information that they need to have the law content. Next slide, please. So the project that we're currently engaged in, and which we're going to go into a little more depth here to discuss the web crawling science and the web crawling art. It's a project for a large financial company that has to be in compliance with laws and regulations, both within the US and around the world. These sites contain information in all kinds of formats because one recurring theme that you're going to hear throughout this talk is that every website is different. Every website is designed by its owner to its specifications, and the actual format of the content can be HTML, PDF, XML, plain text, docx. There's really no control over how the information is presented. The actual target is usually a person reading the screen, so they don't have too much knowledge of the storage format. But in order to download the information, it's very important, and to process it, it's essential to know what the format of the source documents are. So in our project, the first step is to identify the websites of interest. Within those websites, what is the content of interest? Then download it, which I'm saying is a single phrase, but that itself is the subject of our talk. How do you download a site? Once it's downloaded, it is then sent for downstream processing, converted into an XML format specified by the client. That's what Data Conversion Lab has been doing for decades, converting data from one format to another. And that's really the end product of this project, is regulatory content in XML format. And then that format is ingested into the client's document management systems so that the lawyers can then access it. A final step is, once a site has been successfully crawled and ingested, that's just the beginning, because you have to keep up with changes made to the site. So there's a whole different repertoire of software used to monitor sites, detect changes, and process them. Next slide, please. So I'm going to hand it over now to Rich. We're going to go into the more technical part of how the crawlers are configured.
Hi, everyone. Rich Domnelli. So a crawler, in its simplest form, essentially downloads a web page, extracts and parses the links within that page, downloads any pertinent files or images referenced by that page, and then recursively repeats these steps until it's exhausted all the pages available on the site, or all the pages linked to by those pages within the site. And the very first version of our project did essentially these 4 steps, but we discovered a number of problems with this. The first set of problems we discovered was there's several functional issues. How deep do we want to go? Governments and law firms and financial institutions love to produce documents. So while our customer may only be interested in the last few years of documents, we were extracting everything within the site. Also, because we're talking about a web, frequently content will link to off-site content. So the Federal Reserve may reference something in the Federal Register, or FDIC may reference something in the Federal Reserve, and so forth. So what will frequently happen is a dumb crawler will happily follow those links and go off, and slowly but surely you're starting to rival Google in the amount of data you're extracting from the world. We really want to constrain the amount of data that we're pulling down. Plus, we want to be able to pull metadata about the content we're getting. Frequently, a document that's available on a website will have metadata about it, not within the document, but instead on the index page that points to that document. So we'll have a list of documents that we're trying to pull, and on that list, it may say, okay, this document was published on such and such a date and has such and such a number, or belongs to this category. So we want to capture that as well. And the last thing is, we want to make sure that we're capturing the documents in the format that's best for our conversion. Many sites offer documents in PDF, HTML, sometimes text, sometimes XML, sometimes RTF, you name it. It was actually quite surprising, the different formats that are out there. So we want to make sure that we're capturing it in the best format for our conversion needs. On the technical side, ever since Tim Berners-Lee invented the net, 30 odd years ago at this point, or 40 years ago, people have been expanding and building upon that foundation. So every website is slightly different in the way it organizes its content and the way it presents its metadata, making it very difficult to extract just the information that we want from a particular site. Some websites are very dynamic, so they rely on JavaScript. They make AJAX calls or asynchronous calls in the background to pull in pages or to dynamically present the user with information based on inputs that they've done. This makes it very difficult to extract the information from the page because you need to simulate what the user is doing within their browser. And a lot of these pages aren't well indexed by search engines either for the same reason. The other thing we encountered frequently is authentication. Some websites, even if they're not secure or behind a paywall, will require a login or will require that cookies and headers within the website get pushed back on each request. Older websites, and because we're dealing with the government, there is plenty of those, will frequently use ASP.NET and their web forms technology. And what that means is under the covers, there is a form being created and populated with the state of the page. So if you are on an older ASP web page and it's presenting a list of pages to step through, that list of pages is actually being controlled by a form state variable under the covers. And if you look, if you ever examine the page source of the page, you'll see a bunch of form fields that you had no idea was there and isn't immediately obvious from the visual display of the page. Some websites make extensive use of frames. So what will happen is one side of the form will be the table of contents and the other side will be the actual content that we're interested in. So we need to be able to navigate and extract the information successfully from those sites as well. So every website and agency and webmaster does things their own way, and they have their own best practices and approach. They have their own technology stack that they're using, which has its own nuances about how to extract that. So the art of identifying what the information of interest is there and how it's presented and organized is really part of the analysis phase of this project. It's really required to take a step back even before you start attempting to crawl and say, okay, we want X, Y, and Z, and this is really what's going on behind the scenes. So that human analysis is essential before you do that initial crawl for anything but the most trivial sites. So what we discovered that was best is to build a toolkit, a set of, rather than having one size fits all and trying to stuff every conceivable permutation of website and website crawl into one Swiss Army knife, we instead decided we were going to set up a set of tools that we could assemble together in our own way for each site. How we're filtering the sites. Should we, how do we minimize the number of links that we're examining? How do we make sure that we're only pulling it? So in our case, we've decided to use XPath as our page extraction method to narrow down to a particular element within the page or a set of elements within the page. We have a download tool, which basically does nothing more than know explicitly how to download a particular file from a particular site based on what header variables it requires, what logic and what technology are we dealing with, and what does that technology require from a client or a browser to pull down information. How do we extract metadata from the pages? And as Alan mentioned, after we pull our initial load of these sites, how do we differentiate the site from as it currently is versus what we crawled initially? So we're able to do file differences and make sure that we're only redelivering when something pertinent and important has changed. So with that being said, I'll hand it back to Alan to talk a little bit about the analysis and how we categorize sites.
Thank you, Rich. So having learned that every website is different and is the product of the design of their web staff. We did find that we could categorize roughly into 3 different categories: low, medium, and highly complex. So the friendliest sites for crawling, we call in low complexity. Those are consistent. They typically are put together with a standard content management system. They're straightforward. What you see is what you get. And the work that's done in analysis for those sites is basically pulling out of the page the areas of interest, because every site's got navigation on the top and the bottom, maybe on the sides. So you just have to focus in on the part that is essential, analyze how it's presented, what are the keywords, what are the tags, and once that's done, the crawler is basically good to go. And we'll have an example on the next slide. So Rich, I think you can talk to this technically about how it's done.
Sure. So this is one of our low complexity sites. This is the Office of the Controller of Currency. And what you'll see, and this is fairly typical for these kind of sites, is we have navigational Chrome at the top and left and right of the page. But what we're interested in is the information contained in the center, this list of alerts for 2017, each of which is a separate document. So we want to pull everything from that center category. So the first thing we need to do is we need to make sure that all of this surrounding Chrome, the menus at the top, the list of years on the side, the search information on the right, none of that information is coming back on our crawl, and instead we are looking only at this center box. So what we've done is we've created a toolkit that allows us to filter based on XPath queries to say, okay, only show me links that are beneath this container within the page. And then for each of those links, extract the metadata that's associated with it, and then download all the links associating the two and produce output for the conversion tools. So this turned out to be a very straightforward site. It hasn't changed. It's been fairly consistent for us. Each year has its own index page. We love sites like this because they didn't get fancy, very straightforward, very easy to do, and we can bang these out extremely quickly. Medium complexity sites, I'll let Alan talk a little bit about how those are different.
Thanks. So medium complexity is a step above, as the name implies. So they're not as simple as just downloading the content on a page. You may have to go through a web service or a feed in order to get the data in the first place, which is a totally different format from the way it looks to the user. Or you may need to crawl the page at different levels because the data is not presented in one place and is not obviously seen until you go deeply into it. And go ahead, Rich, this is a perfect example of Federal Register. Rich, do you want to explain the complexity of this site?
Sure. So the Federal Register, as you see here, is produced every day. There can be anywhere from a few documents to several hundred documents published on a daily basis and presented in a list on this page. The documents are organized by department. They exist in both HTML and PDF format, but because this center box is built dynamically, it is a difficult site to extract directly. However, because the Federal Register is so commonly required across the web and by so many different companies, they actually have their own API that gives you the Federal Register in XML or JSON format with a list of links and all the new documents. This is what that looks like. So this is the Federal Register for January 8th, and it gives us the titles, what departments they belong to, the URLs, which are permanent URLs for both the HTML and PDF versions, as well as a whole bunch of other metadata, which is fantastic. We crawl it every single day. We pull all that information in. We download all the files. We download all the associated images and documentation. You can see from the URLs they present there, some of the data is hosted locally and some of it is hosted on S3. No problem. We just chew through it every single day, and we do, hundreds of thousands of documents from this feed without any difficulty whatsoever. On a similar note, we have the FDIC press release site. This actually started out as a low complexity crawl with a very simple list of documents that we could extract using much the same method as we did in the OCC alert site we saw earlier, where we had surrounding Chrome, but we were only really interested in a list of documents from the sender and the metadata about those documents. However, about 9 months ago or so, they changed the way they did business. So the site went through a major redesign, and now what happens is this page is built dynamically using JavaScript. They have an XML listing all of the new documents, but that XML doesn't actually even doesn't even contain URLs. Instead, they dynamically build the URL based on the contents of that XML. So what we needed to do for those is turn around and mimic that logic so that we could also build the URLs dynamically. And this is what that XML looks like. And you can see it has titles and the date and the update date, but it doesn't actually say, okay, this is how you get it. And what their JavaScript did internally was they extracted the document ID and built a URL from that. And we mimic the same logic. And then we come to our favorite subject, high complexity sites. And I'll let Adam talk about some of the difficulties we encountered there.
Thanks, Rich. So this is what really makes this project unique. So the medium complexity is a challenge, but as Rich showed so well, once you figure out where the data is and how to get it, it's regular, it's obtainable, and it's repeatable. The high complexity sites, catch-all, they've got something unique. They've got either a problem or they've got a challenge with the way they do things. And some examples would be large amount of JavaScript is needed or form processing. Browsers have to be simulated because they're not designed to present any data to a request. They are only designed for an actual browser, presuming there's a human being behind it. They've got throttling. They've got authentication requirements. And believe it or not, they may be bug-ridden or unstable. Those and workarounds are required for every single one of these. And those are the ones that, as I said, make this project so unusual and interesting. One example would be Hong Kong, and Rich will show you exactly what it looks like just as an overview. The site is designed for a browser, and when you're in the browser and you think you have a page, you don't. You really just have the beginning of the page, and when the browser detects that you're getting near the bottom, it goes out and fetches more of it. Which is why when we first downloaded the pages, we thought we were all done, and then turned out through our manual review that the documents were really much longer than what had come down. So I'll let Rich explain what's behind that.
So what you see here is this is the index page from the Hong Kong legislation site, which isn't too bad, and we were able to get the list of chapters and instruments, as they call them, to download directly. When you click on the link from within this page, it brings us to their document display utility. And what we have highlighted on the bottom of the screen here is what happens when you reach the end of this document preview window. It will go out and pull chunks. So they display, because these documents are quite long, what they do is they display the first page or the first couple of pages of the document and then dynamically fetch as you hit the end of that scroll. They will keep adding to the bottom and adding to the bottom and adding to the bottom. So the challenges that we encountered here was, how do we simulate that, obviously? But the other challenge we encountered, which didn't become immediately apparent, is how do we know when we're done? Because the documents don't really have a consistent indicator that says the document is complete. And because behind the scenes, they are maintaining the logic for figuring out how long a document is internally, and it's opaque to us, what we had to actually do is build a custom browser that went out, pulled in these documents, looped through all of the chunks, and kept trying to loop until the document stopped changing in size, at which point we assumed we were done. And even then, we went through and manually reviewed each of the documents that we pulled down to make sure that we had gotten the complete content, only because it was such a twitchy site to deal with. We also encountered, even from a normal browser, we encountered some problems with the site as well. So it was a challenge. And in this case, we had to actually reach out to the webmaster a few times to understand what they had done. So as we've talked about, one size doesn't really fit all. Web pages are designed by people. They rarely share layout or technology. By building a toolkit and constantly expanding that toolkit, you're in a much better state to reuse components, to have that tool chain that you walk your project through, rather than trying to stuff everything into one gigantic statement. Or one gigantic program, sorry. If the site you're crawling is using a standard content management system, Drupal, Joomla, WordPress, or anything like that, your life is much simpler because it's not custom. There are already built-in tools within these content management suites to make it simpler to crawl, because most people want to expose this information to search engines and pull in web traffic. That's unfortunately not frequently the case for these government websites. Instead, they build custom suites which requires you to do custom crawls to pull it. Again, metadata acquisition is also easier when there's a new standard coming. It's a few years old now, but not too many people have adopted it, which is semantic web tagging, where even if the element doesn't have a visual component, it will be surrounded with a tag, and there will be metadata within the document itself that allows you to extract the information much simpler rather than doing the scrape off the page. I'll let Alan talk a little bit about monitoring for changes, and we can talk about the technology behind that.
Thanks. Before I do that, I just want to emphasize what Adam said at the beginning. We know we're going very quickly and quite deeply, so please generate some questions, and we'll definitely have time after we're done to try to answer what we can. Going back to something mentioned earlier, getting the web content the first time is one challenge, but once that's done, the reward for success is, now, thank you very much, now we need to keep it up to date. How do we monitor a site that we've successfully ingested for its changes? Clearly, we cannot just keep on ingesting the same site day after day after day. We have to focus on what's different. So the gut reaction would be, well, no problem, RSS is designed exactly for that. It's designed to let you know what's different. Next slide. The problem with RSS is the theory behind it is great, but it only offers what it wants to offer. First of all, many sites don't have RSS. Those that do have RSS often limited to just the most recent changes. And more importantly, it's controlled by the website. So it offers changes that it decides are significant. Now, that may have too many changes where they may just be announcing a lot of information that's not legally related. It may just say, you know, we're moving to a new office or whatever they want to say, and they may leave out information that's essential because they didn't consider it to be a major release. But for those legal departments that have to ingest the content, there really is a change behind the scene that was not advertised in RSS. So it's really not practical to rely on RSS to keep a crawl up to date. Next slide, please. So Rich, I think you can talk to the practical solution.
Sure. So much like Google and other search engines do, what we decided to do is recrawl the site periodically. Even if the site offers an RSS feed, or in some cases they offer a physical update page, what happens is webmasters are human, and sometimes they don't realize a page has changed because they're in charge of the site, but other people may be doing content changes. Or in some cases, they don't feel a change is pertinent to list. So frequently those update pages are nowhere near useful, honestly. So instead, we again periodically crawl the site, much like the search engines. And then comes the next challenge. How do we determine whether a site is meaningful? So what we do is when we recrawl the sites, we again constrain what we're looking at. We constrain within the document itself, we constrain the areas that we're comparing within the document, so that if we're looking at an index page, we are only looking at that content page, because other things may change around that content area, but only that content area should be changed. If we're looking at a HTML, Word, PDF, or RTF document, we want to make sure that we're doing a textual comparison of those documents and ignoring headers and footers and ignoring images or other things, or logos or that type of thing, and making sure that we're only really flagging a change when it truly is a content meaningful change. So what we did is we built a differencing toolkit that allowed us to go through sites very quickly to see if there's been a difference. You know, at a very crude level, we do a hash comparison to see if the file has changed at all, and if it has, then we push it down to a succession of deeper and deeper filters to make sure that it's a meaningful change. And when it is a meaningful change, we build a presentation layer that basically says, okay, this document has changed. Here's a comparison to the old document and exactly what bits are different. One of the things I want to mention here is, because we're hitting these sites every day, is you have to be polite about your web crawling. There are dozens of search engines out there. There are lots of people hitting these websites on a daily basis. And if you're hitting these pages aggressively, you know, you write a multi-threaded application that's spawning dozens of threads and slamming this site and pulling it as quickly as possible, that is essentially going to start bringing the site down. And many websites have distributed denial of service things to prevent people from hitting it in exactly that fashion. So what we discovered very quickly is, if we're too aggressive, we will be shut down. We'll start getting denied, and we'll get and our IP address will be blacklisted. So instead, we designed our crawl to be as gentle as possible. We have gap times between each request. We make sure we wait. We make sure that we're not spawning more than 3 threads against any particular site, to make sure that we're not aggressively pulling things. And we're also making sure that when we are crawling a site, we're not hitting them every 15 minutes or every 20 minutes to see if there are any differences. And there are some sites that change that frequently. But we want to make sure that we're being as polite a web consumer as possible, so that these sites don't shut us down. So, Alan, I believe the closing statement is yours.
Sure. So going back to our opening title, Web Crawling Science or Art, it's really both. Web crawling is an art. As we've shown, it cannot be totally automated, because every site is so different, both for the initial downloading of a site and for the ongoing processing of changes. On the other hand, it's not entirely an art. There's a lot of science that we've found can be applied to it. As Rich has shown, there's toolkit approaches after analysis that we could reuse tools successfully between sites. We've found that a differencing tool is phenomenally valuable for ongoing maintenance, which is, it's not enough to know that the page is different. It's very important to know how is it different, because remember, the end product is an XML conversion of the page. So if that is not going to change, then the page really hasn't changed. So we have put together the art and the science for a very successful set of sites that is ever increasing. And as the last line says, just when you're ready to take a little break, then find out that the website has been redesigned without any notice, and it's back to the drawing board to get that one back into the hopper. Next slide. So Adam, do you want to take the questions that may have come up in the meantime. We'll try our best.
Great, thank you, Rich and Alan, for this very informative webinar. We have several questions that have been submitted. The first one being, you mentioned the Federal Register API. What's your discovery process to learn about better access points like that?
So what we discover, our first approach when we're hitting a website is to typically try a fairly generic crawl after doing an initial pass and discovering what our containers are and so forth. However, better websites will say down at the bottom, or will have some information within the site that says, you know, we supply these pages within GitHub, or we supply an API to access these pages. So it's a combination of things. There isn't, if they have a notice like that, that's great. For the purposes of the Federal Register, we had reached out to the webmaster because we were having some issues paging through their site initially, and his response included, well, we do have an API that we're in the process of publishing. Here it is.
Great, thank you, Rich.
I just want to add to that. I'm sorry. I just wanted to add one interesting point to that excellent question, is that we actually find through crawling that there are often errors on websites because nobody has really reviewed them thoroughly in an automated manner the way our software exposes. And as you can get, we have varying reactions where some sites are very happy for the feedback and make an immediate change, where other sites don't know what to do with the feedback or totally ignore it. But it is interesting that nothing is perfect, and we often, through our automated tools, find inconsistencies within the sites.
Great, thank you, Rich and Alan. The next question has come in is, what do you do with all this data after it is crawled from the websites?
So, as I mentioned earlier, the point of getting the data is to convert it into a format that can be ingested. For this particular project that we are giving examples from, the end users are lawyers who need the laws so that they can reference them within documents. They can cite to them specific locations within the law. So what we do with the documents is we send them through a whole series of conversion steps, which is, again, something that Data Conversion Lab has been doing for 35 years now, which is converting one type of content to another. So once we've ingested it into whatever HTML, XML, PDF, however it came in, we run it through our assembly line, and outside the other end comes XML of the type that the client requested, so that they can then ingest it into their internal proprietary systems and work with the data as needed.
Rich, do you have anything to add?
The only other thing I'd mention is one of the things we do in addition to doing that conversion is we do maintain a snapshot of the website every time we crawl it for comparison purposes and to make sure that we can do differencing against it. So that is always maintained and there persistently, which, you know, thankfully storage is cheap at this point, but you can imagine grows over time.
Great, thank you. Thank you, Rich and Alan. The next question has come in is, how do you handle sites that deny programmatic connections?
There's two approaches to that. One, it's almost impossible to detect a program if you really are determined. What I mean by that is a web browser sends a set of specific headers to indicate that it's a web browser. So we can emulate those same headers, user agent, the accept strings, there's a number of others, as well as being able to accept and reflect cookies back to the website, which is typically what they're doing to do it. The other issue we've encountered and handled is sites that limit the number of times that you can access them repeatedly. There's a couple of flavors of that. The most common one is after you do 10 or 15 or 20 or 100 requests against the site, they'll come back with a CAPTCHA page that you have to fill out or something like that. The way we handle those is we have an array of IP addresses that we cycle through to look like a different user on each request to the site. So it doesn't look like we're sending 100 requests to the site within an hour. Instead, it looks like we're sending, 5 requests or 10 requests within an hour.
So I just want to add to that, make it clear we're not involved in any kind of hacking project or trying to get data that's not meant to be gotten. We're talking about legal and regulatory data that is published for the public to get, and sometimes they're required to get it off the website. So if the website makes it difficult to get, that is just another challenge for us, but it's public information, it's meant for the public, and therefore we do what we have to do to allow the information to be gotten from the site that's presenting it.
Great. Thank you, Rich and Alan. The last question that's come in is, can you speak about how to detect that there is new information of interest on a given website?
As we talked a little bit about, we have a couple of different methods. Obviously, some sites will have an update page or an RSS feed or something like that, which unfortunately is rarely of use, or if it is useful, it may just be a trigger to say the site has changed, but not actually give us enough information to replace a crawl. So typically what we're doing is we are revisiting the site, running through it as if we were doing a crawl, and at least looking at the index pages. Even if we're not going through each and every document, we'll look at the index pages to see if they are indicating that their change has been made. Many of the sites we deal with are press releases or notices or bulletins or something where they're adding to the sites, but they're rarely changing older documents. So in those type of sites, looking at the index pages are enough. We can say, okay, they've listed 3 new documents. We're going to pull those 3 new documents and move on with our life. Some of the sites, we have to do a full crawl and we do our comparison. And at that point, we have our differencing tool to indicate whether or not a meaningful change has occurred. And sometimes it takes us a few times to get that right or dialed in perfectly to make sure that we're only identifying things that are absolutely important as far as a change. And we fire that off periodically, pretty regularly actually, so that we can know exactly when the site has changed, exactly what the changes are, and present it to our customer in a standard format. Alan, anything to add?
I would just add an interesting tidbit. The U.S. Code is a very commonly requested site. U.S. Code is the codification of all the laws of the U.S. and put together in a logical order. It changes pretty frequently, and they try to make it friendly by highlighting on the website each release point. When something changes, they put up a new, what they call release point, and they actually highlight in bold what's changed. We found that it's pretty good, but it's not perfect. In other words, we actually don't necessarily believe when they say things have not changed, and we found examples where there were changes to the text, even though it wasn't highlighted. I actually spoke to the department, the legal division that maintains it, and they were explaining that they didn't feel that it was a change of interest. It was an editorial change and not a change to law, which is fine for their purposes, but for the purpose of getting content and alerting our customer to any changes to the content, we've found that there's just, even on a great site like the U.S. Code, where there are people devoted to keeping it up to date for the public to consume, there's no reliable substitute for actually getting the files and checking them ourselves.
Great, thank you, gentlemen. We had several more questions come in. The next one's rather long, so please bear with me. How are you handling websites that are moving beyond plain text to more rich media formats, where the information is dependent on a combination of text, video, audio, and other integrated documents?
Okay, that's a great question. I'll just, from the high level, I would just respond that, again, our project is designed for regulatory data, legal data, and in that sphere, the documents are required. Basically, it's an equivalent of paper with sometimes some images embedded within the text. But the law, even though there are many sites that may include videos as part of their content, the law is not set up that way. So frankly, our toolkit hasn't yet been developed to have any need to deal with non-text input, except to load it down as a link or as an image, rather than extracting the data from it.
Although I have to say that I think some video presentations for these laws could be quite entertaining.
Thank you, gentlemen. The last question has come in is, do you have some crawls that are standard, or do they all have to be individually done?
So we do have a number of crawls that are generic enough that just runs through the toolkit by itself, you know, and we supply the toolkit a couple of command line parameters of XPaths and things like that to extract it. What we discovered fairly early on is, even for the purposes of the crawl, that usually covers us. Where that we kind of trip up on is extracting metadata from the pages, because even though we're just pulling down these websites, we also want to extract information from the index page itself about document numbers or authors or you know, the typical metadata you see when you're looking at a list of documents. You know, when it was published, what formats or is it available in, or you know, that type of thing. So we have a great way of extracting links dynamically through a command line method. We don't have such a great way or standard way of extracting the metadata, unfortunately. And part of that is the source that we're dealing with isn't consistent enough to allow us to do that, short of doing something like natural language processing and that type of thing, which we have fallen to on a number of occasions to extract dates. But it's not really tagged well enough for us to say, okay, well, if we're looking for authors, it's always going to be consistently tagged as author within, you know, with a semantic tag or something like that. As people start adopting semantic tagging more and more, which there's some talk about it being required for regulations, that may change, and that would be a very, very pleasant change, especially from my perspective, since I frequently am sitting there trying to puzzle out where to grab this information or how to grab this information consistently. But we're not there yet. So crawling, yes. Grabbing metadata, not so much. Alan?
Great.
Anything to add?
No, you've covered this one perfectly. Thank you.
And thank you, Alan and Rich, for a very informative webinar. And thank you, everyone, for attending today's broadcast. This will conclude today's broadcast, and you'll be able to access the recorded version from the webinar archive section of our website located at dclab.com. Our next webinar will be Thursday, January 18th at 1 p.m. Eastern Time, titled Finding Evidence in a Mountain of Data, Leveraging MarkLogic to Gain Insight into Residential Mortgage-Backed Securities Data Before and After Legal Proceedings Have Commenced, being presented by David Carrott, Principal Sales Engineer of MarkLogic, and Michael Will, co-CEO and founder of ESI Laboratory. Thank you, everyone, again for attending, and have a great day.